Hello everyone, this is Dr. Lennon, and we're going to go over the final exam review. So the final is cumulative, 10 questions. So let's start with the first one, just combining some algebraic expressions using like terms. So the first thing we want to do is expand using the distributive law, so multiply the 3 through the first set of parentheses. We get 6x minus 9y. And then for the second set of parentheses, the negative 8 gets multiplied by both terms. So it's going to be minus 16x minus 48y. And then we can add the numbers in front of the x's and add the numbers in front of the y's. So 6 minus 16 leaves us with negative 10x, and negative 9 and negative 48 leaves us with minus 57y. And that's it for the first problem. For the second problem, we're just solving a linear equation. This is just 2 steps. Just get the x's on one side. So we do that by adding 6 to both sides of the equation to, I copied it down wrong. It should be equals 21. We could solve it with 27. The answer just doesn't come out to a perfect integer. Anyway, so when you add 6 on the left, they cancel. And on the right, 21 plus 6 is 27. So then just divide both sides by 9, since x is being multiplied by 9. And we're left with just x equals 3. So that's the solution to problem number 2. Okay, so for problem number 3, we need to graph this line. So we use the y-intercept and the slope. So the y-intercept means it hits the y-axis at 5. So 1, 2, 3, 4, 5. It's going to hit the y-axis right here. And the slope is negative 3 over 2. So that means if you move from the y-axis down 3 and right 2, you will find another point on the line. And then once you have 2 points on the line, that is enough to sketch the graph. 2 points uniquely determine a line. And that's all you have to do to graph a line given the point, the slope-intercept form. For problem number 4, we want to find the equation of a line. So to do this, we first find the slope. So remember, the slope formula is given by y2 minus y1 divided by x2 minus x1. So in this problem, our slope is going to be 4 minus 3 divided by 3 minus 1. So that comes out to 1/2. And then we know that the equation of our line has to look like y equals 1/2 x plus b, which is your y-intercept. So we can plug in either of the 2 points and solve for b, and that'll give us our equation. So let's plug in the first pair. So 3 replaces y, and 1 replaces x. So to combine the fractions, we want to get a common denominator, which is going to be over 2. So 3 is the same as 6 divided by 2. This equals 1/2 plus b. And then we can just subtract 1/2 from both sides. And we see the value of b is going to be 5 over 2. So the equation of our line, the final answer is y equals 1/2 x plus 5 over 2. And that is the equation of the line that passes through those points. For number 5, we're trying to solve a system of equations. So when you have 2 linear equations like this, there's 3 possibilities. Either they meet at a single point when you have one ordered pair solution, they're parallel where you have no solutions, or the equations actually represent the same line, in which case you would have an infinite number of solutions, all of the ordered pairs that would satisfy the equation of either line. So the method I prefer here is the elimination method. So we just pick a variable, either x or y, and then we want to eliminate it. So that means they'll have the same coefficient with opposite signs, so that when you add the equations together, the terms containing that variable will vanish. So let's suppose I want to get rid of x. Then if I multiply the top equation by 3, I'll have 6x, and if I multiply the bottom equation by 2, I'll have minus 6x. So when I add them, the x's will disappear. So I'm going to multiply the top equation by 3 and the bottom equation by 2. But in doing so, remember that you have to multiply all 3 terms in each equation by that number. So I have 6x plus 15y equals 36 on top, and on bottom I'll have minus 6x minus 8y equals 20. So then we want to add them up. So the 6x minus 6x will disappear. 15y minus 8y is 7y. And 36 plus 20 adds to 56. So if we divide by 7, we see the y-coordinate of our solution has got to be 8. So y is equal to 8. But we're not done. Remember, the solution is an ordered pair, so we want to plug that in to one of the original equations. So let's say we plug it into the top equation. Then we'll have 2x plus 5 times 8, and that'll equal 12. So then what we want to do is solve for x. So 2x plus 40 equals 12. So we just need to subtract 40 and divide by 2. So we end up with 2x equals minus 28. And dividing by 2 leaves us with x equals minus 14. So that leaves us with our solution. So the solution is minus 14, comma 8. And that's it. So these two lines in this case intersect, and they intersect at that point, negative 14, comma 8. Okay, so for number 6, we want to factor. So the key thing when you have two terms like this with a minus is remembering the difference of squares factorization method. So what that says is if you have something that looks like a squared minus b squared, this can be factored as a plus b times a minus b. It doesn't work over the real numbers if there's a plus in the middle. So this only works for us using the difference of squares. So the important thing to recognize in the above is 625 is 25 times 25, and 16x to the fourth is 4x squared times 4x squared. So this will factor as 25 plus 4x squared times 25 minus 4x squared. Then what we can realize, if you look at the first term, it's a plus in the middle, so it doesn't factor any further. But the second pair, 25 is 5 times 5, and minus 4x squared is 2x times 2x. So I can factor this one step further. So I have 25 plus 4x squared, and then the second set of parentheses can factor into 5 plus 2x times 5 minus 2x. And we're all set. Okay, so number 7 is solving a quadratic, and we'd like to do that by factoring if we can. So the first thing we're going to do is we're going to subtract 10x from both sides of this equation to put everybody on one side and 0 on the other. So we have 8x squared minus 10x plus 3 equals 0. And then how does this factor? Well, remember we have the method that we typically like to use is factoring by grouping. So multiply 8 by 3 and we get 24. Then we need two numbers that multiply to positive 24, but when you add them you get negative 10. So in this case, negative 4 and negative 6 will do the trick. So that means basically we want to rewrite that minus 10x as minus 4x minus 6x. So we can write the equation as 8x squared minus 4x minus 6x plus 3. And then we want to factor each pair using the greatest common factor. So 8x squared minus 4x has a common factor of 4x, and we'll be left with 2x minus 1. And minus 6x plus 3, we can take out a negative 2, and we'll also have 2x minus 1. Oh, sorry, a negative 3. I don't know why I said 2. So we're going to take out a minus 3. That's the GCF of the second pair. So 2x minus 1 equals 0. So then our two factors will be the 4x minus 3 and the common 2x minus 1. So when you have two things that multiply together that make 0, the zero product property says that one of those two factors must be 0. So either 4x minus 3 equals 0 or 2x minus 1 equals 0. So we want to solve each one of those linear equations. So the first equation can be solved by adding 3 and then dividing by 4. So we get one of our solutions, x equals 3/4. And then the second one is solved by adding 1 and dividing by 2. So we have 2x equals 1, divide by 2, and we have our other answer, x equals a half. So those are the two solutions. And that's it for problem number 7. So for problem 8, we want to solve using the quadratic formula. So let's remember what the quadratic formula says. It says the solutions to ax squared plus bx plus c are x equals minus b plus or minus the square root of b squared minus 4ac, with everyone being divided by 2a. So in the above equation, we just want to identify a, b, and c. So a is going to be 3, b is going to be minus 1, and c is also going to be minus 1. So if we plug these into the formula, we get x equals, if b is negative 1, the opposite of negative 1 is positive 1, so 1 plus or minus the square root. Remember, whenever b is a negative, we want to put it in parentheses before squaring it. So negative 1 squared minus 4 times 3 times negative 1, with everyone being divided by 2 times 3. So we end up with x equals 1 plus or minus the square root of 13 over 6. So if you want to write that in set builder notation, or if they ask you to specify the answers, the solution set here would be 1 minus the square root of 13 over 6, comma, 1 plus the square root of 13 over 6. And that's the quadratic formula. You just plug everything in and then simplify using the arithmetic. Okay, so for problem number 9, we want to identify the sine, cosine, and tangent of the specified angle theta. So remember, basically this is determined using the acronym SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over the hypotenuse, and tangent is opposite over the adjacent. So our three trig ratios they want us to identify based on where theta is located. 5 is the opposite, 12 is the adjacent, and the hypotenuse is the longest side, 13. So the sine of theta will be 5 over 13. The cosine of theta is the adjacent, 12 over 13, and the tangent of theta is the opposite, 5 over the adjacent, 12. And that's it. So those three ratios are what they're asking for. So basically this is all of our work right here. The diagram was given to us. So for number 10, the last one, we want to solve for the missing parts of the right triangle. So we have a right triangle. Again, the capital letters denote the angles, and the lowercase ones denote side lengths. It says we want to round our nearest answer to the nearest thousandth, so that's 3 decimal places. So again, since the angle is in degrees, make sure your calculator is in degree mode, and then you are all set to go. So the first thing to figure out is we know A and B, since it's a right triangle, have to add up to 90 degrees. So angle A just has to be 90 minus the given angle B, 35.8. So angle A is going to be 54.2 degrees, and that's as exact as you can be with A, so you don't need to put any trailing zeros or anything like that. Since angle B is only given to 1 decimal place accuracy, that's the case with A, since it's exactly found. If the decimal had more places, then you might have to round, but it doesn't. Okay, so now we want to find the sides A, B, and C. So we want to use the trig ratios to do that. So let's go ahead. If we just want to use angle B for all 3 of them, we can. So let's say we want to do the sine of angle B. So if we do the sine of 35.8 degrees, that is going to equal the opposite of B, which is unknown, over the hypotenuse, which is known, which is 14.1. So basically, you can just cross multiply to solve for B. So if you do 14.1 times the sine of 35.8, we get the value of side B. So if we want to round that to 3 places, let's go ahead and put that in our calculator. So if we do 14.1 times the sine of 35.8, we end up with 8.2479. So since the fourth decimal place is 9, we round that 7 to an 8. So our answer here would be 8.248. And that is the length of side B. So now if we look at the so the last thing we need to solve for is A. We can still use angle B. If we want to use angle B, A is going to be the adjacent side. So we could use the cosine. So the cosine of 35.8 would equal A divided by 14.1. And then cross multiply again, we get 14.1 times the cosine of 35.8. And that's going to be the value of A. Again, you can use other trig functions if you want. It's purely preferential, but you should get the same answers. So if we do 14.1 times the cosine of 35.8, we end up with 11.436 when we round to 3 places. And that is it. So typically on these solve for the missing parts of the right triangle problem, 3 things will be known, and there will be 3 things left to solve for. And always one of those things, when it's a right triangle, is going to be angle C. Angle C is always 90 degrees. So we found all the missing parts, and that's it for this problem. So hopefully you went through that and everything made sense. And if so, you are ready to take the final exam. All right, this is Dr. London signing off.